think it might also be that there's an outside.
Oh yeah, 95 was shut down. Yeah, it's a mess. So, all right. So today's lesson should be the end of a lot more of the definitions. We're going to start going into more calculations and graphing and drawing and stuff, starting in chapter 3, which will start next week. And then chapter 4 is where we really start getting into more of the harder formulas and a little bit more of the math end of it. But a lot of chapter 1 and chapter 2 was designed to set the stage and get you to understand why we're doing some of the stuff and what the stuff means. So we're going to start looking at graphs today. And there's two major styles of graphs that you typically see, and how that data is organized is important. So the first set of graphs that we're going to look at is known as time series. This type of graph is actually one of the most common graphs you're going to see. This looks at data over time. So if you want to look at how gas prices change over time or how the climate's changing over time, those things are all where the x-axis is going to be your time and the y-axis will be what your data points are going to be. So that's known as a time series. So let's look at one. So I don't know if you guys can read that or not, but yes. Sure. That's right. I can go back and I can talk about the next page. So the next list we're going to look at is batting averages in the American League, for the American League batting champion from like the 1950s till I think it was last year. All set? Okay. So so we have from 1970 actually. So you've got this chart of data. If you were going to look at this chart of data, you've got this information. What trends can you tell me by just looking at this chart of data? And I really can't make it bigger, unfortunately. So, but here's actually, even though I can't make it bigger, there's one thing you can get. It's a lot of information just on one little thing, and it's hard. Like, you're really going to have to look at it to figure out like what's going on, right? What if I showed it to you like this? Is that easier to start looking at things? Yes. So one of the big reasons we use graphs is the whole concept of a picture's worth 1,000 words. When you look visually at something, we can get a lot of information about it. We can start seeing what's going on. We can start seeing what's happening. So here is our batting averages from 1970 till 2018. All right, so what trends do we see? Huh? It's baseball. It's batting. So it's how much, it's the winner. So in baseball, when you hit the ball, it's normally right around like anywhere between 300 and 4 or 30% and 40% of the time you hit the ball. That's for the good hitters. The bad hitters are around like 20% of the time they hit the ball. And those are normally ones that hit home runs almost every time they hit the ball. But so that's the lower end of the batting average. The highest batting average ever was 416. So we can see a couple spikes getting close to 400. But the majority of them are pretty close to the middle, right? We don't really see a trend going up or a trend going down. They tend to fluctuate right around that middle line, right? That's important because when we're looking at the two types in time series, we have the centralized point where the data seems to fluctuate around a central point, or you have ones that are trend lines that have a tendency to change over time. This is one that fluctuates around a certain point, right around 350-ish or so. Anybody know baseball in here? Jeez. All right, what sports do you guys like? Okay. Rugby? Oh, hockey. I'm like, rugby? I've seen the tickets to the Wolfpack. So it's like, I like hockey. Football? Okay. So Don't bring in sports examples. Got it. All right. So this wasn't my example. This was the book's example. But it was a decent one to show you the centralized line. All right. Let's look at this one. These are acres burned by wildfires in the U.S. So from 1983 to 2016. Anybody know anything about forest fires? Yes.
Just any fact, is that what you're asking for? Majority of the time, it's not actually started by campfire, it's started by parties going off. Like you give a party, celebrate with a firecracker or spark.
Yeah. That's actually not the majority of reasons forest fires get started. The number one reason forest fires get started is lightning. Yeah, lightning starts most of them. We've had forest fires forever. Like forest fires have gone on for the entire history of the world. It's actually how the climate actually cleans out a forest and then replenishes it. So when you burn things, the actual like the soot and everything else gets down in the soil and actually replenishes the soil, which helps it grow back better.
Or like controlled forest fires.
Yeah, which we don't do very much anymore, which is one of the reasons we're starting to see a lot more forest fires. We don't do those controlled burns. We don't do the clean outs and stuff like that. So there's a lot more ground stuff and everything else, which is causing a lot more forest fires. And we're living where forest fires would exist, which causes a lot more people to notice them, which is also a problem. This year, we happen to know about forest fires that were happening up in Canada just because it smoked us out. Back in May, it was horrible. Like beginning of June, there was days that it was really bad. Some of the pictures from New York looked like post-apocalyptic, like it was orange. It was crazy. All right, so this is forest fires, again, by year. So this is a time lapse or time, what do they call it? Time series? Time series graph. But now, if we look at this as a graph, here's our graph. Right. So now in this one, is it going across the central point, just oscillating back and forth, or is it have a trend where it's going up? There's a trend going up. So we can create like a trend line for this one. Okay. So that's the two types of time series you're going to have. You can have one oscillating across the central point, or there's going to be trends to the data. All right. I want to look at this one in 1 second. We're going to do divorces in a minute. All right. The next set of data that we want to look at, or the next set is called cross-sectional data. Cross-sectional data is looking at a bunch of different stuff at the exact same time. Okay. So say we had a chart and showed us the average gas price in all 50 states this week. That would be cross-sectional data. Okay. Or if I had a chart and I put everybody's bank account balance on a list, that would be cross-sectional data. All right. So the difference between the time series and cross-sectional data, time series is over time, and cross-sectional data is a moment in time. Now, you'll notice that I don't have any graphs for these, for the next couple ones I'm going to show you. If we're looking at cross-sectional data, it's a lot harder to make that line graph because those points are for individual things. There's no organization to it, so we can't like organize it in a specific way and whatnot. So you typically see this data in tables. So this is the amount of CO2 emissions per capita by state. So actually, if you were to guess which state in the United States has the highest, I know the answer's up there, but if before you saw this graph, you were to guess, which state would you believe would have the highest per capita carbon dioxide? Yeah, you think California, Florida, Texas, the big states, right? That's methane, not carbon monoxide or carbon dioxide. which is a massive greenhouse gas actually. And they're actually saying that that's causing a lot more issues than we think. But it's Wyoming. Why would it be Wyoming? Anybody know anything about Wyoming? Yeah. Pretty much. Wyoming is the smallest state in the country in terms of population. There's about 700,000 people that live in Wyoming total in the entire state. And it's about, I think it's almost 30 times bigger than the state of Connecticut. It's massive. It's pretty much just empty. So when you're looking at, this is one of those ways that, and if you look, the ones that we all said, New York, California, are like down towards the bottom. Hello, you're fine. I know, traffic was crazy today. New York, California is right down the bottom. Why? Their populations are so large. So when you look at everything going on in that state and you break it down by how many people there are, the big manufacturing plants and stuff like that that actually do produce a lot in carbon dioxide gets split over more and more people. So it doesn't seem as bad. All right.
But also, like, they have to go somewhere where there's a lot of people, so they have to work.
Yeah. Exactly. So you'll figure like, and that's part of the problem. Like you have industry where the most people are. It's like that's just the way it happens. So this is known as cross-sectional data. I think that was the last one of that one. All right. Now let's go back to divorces. I literally talked about two things and I'm going to mention them again, so you're fine. All right. So here is the divorce rate over time. So what kind of graph is this? This is a time series. Like I said, the majority of the ones you're going to see are time series. All right, looking at the graph, is this going over a centralized point or is it, is there a trend? Okay, what's the trend? All right. So if you're looking at this from 1895 till, well, this was 2015. I don't think it's changed much. Actually, it's still keep going. The trend's continuing the way it is from 2015. It's gone up. Okay. If we look after the 1970s, what do we notice the trend is? It's high, but what's the trend? It's starting to decrease, right? Okay. Why? Why would the trend? So we always talk about divorces as being this major thing, right? There's so many people getting divorced. At one point, like the statistic came out, it was like 50% of the people, 50% of marriages fail and you get divorced. That's what was way off to begin with. But we've always talked about how high divorce rates and stuff is. This graph tends to show that divorce rates are continuing to go down, and there's only about just over 3 out of every 1,000 people that are divorced. So the question I asked is, does anybody have a reason on why? Yes.
Maybe initially divorces were hard to get, so when it became easier to get, there was a big spike in people finally got them. And then once that rate coming out, it's gone down.
What was happening in 45 is the next before.
Yeah.
So you're looking at big world.
So yeah, we had a big spike in after the 1945. A lot of people got divorced because their husbands came home and they didn't realize they were going to come home because they got married like right before they went to war. So that was a spike there. What happened in the 1960s and 70s? It had less to do with the Vietnam War. Had less to do with that. What was the big thing that happened in the 1970s to the U.S. family? Women liberation. Women wanted to go to work, make money. The big thing in the 1970s. So they were like, I don't need you anymore. Which caused the spike to even go into the 80s. That's that trend. But now it's starting to go down.
I was gonna say, I feel like even now, it's like it's more socially acceptable to like have kids and like start a family without being married. So
You're hitting on a very good thing.
to be divorced.
Right. You have to be married to be divorced. You hit it. That's the keys. This chart shows marriages since 1900. Marriages are going down. Marriages go down, divorces go down. Yeah, marriage is not that big of a deal anymore. Well, it still is. There's still a lot of marriage, but I mean, like, it's not like it used to have to be. So when you were looking at one point, like almost everybody was married. Like you basically had to get married. You had to have married, start a family, and everything else. That's just the way it was. But after the 1970s, it has basically continued to drop. So now only 30 out of every 1,000 people or 100, yes, it's like 30% of people are actually married, and it's continuing basically to drop off. And that's a lot of the reasons. It's more socially acceptable just to be a non-traditional family today than it was in the past. So if that's going down, divorces have to go down. But that's one of those things that when you start to look at graphs, if you look at just the divorce graph, it's like, oh, that's great. Back to more traditional family values. People are staying together more often. Like, but no, there's always things behind the things that you need to understand. So when you're looking at graphs, those are types of things, some of the things you want to look at. And you always want to ask that question, why? What's going on? Why is this happening? Especially if it's counterintuitive to what you believe would be happening. All right, so we're going to hide this one for a second. And I'm going to go this one. All right, so we've all heard, what was it? July was the warmest month in world history. I think that's what they said. That was the headline. July was the warmest month in world history. So the last 9 years are the warmest on record. And this is the graph they used to show how global warming is this major thing. So looking at this graph, does it look like global warming is a major thing? Yeah. So this is going back to the 1880s, which is about when we started collecting meteorological data. So most of our data that we look at in terms of weather and stuff like that goes back to the mid 1800s, depending on where you live. No one then was like the national level meteorology really started in the 1880s. So this shows that whole thing. So there's a couple of things to look at in this graph. The first one is it's based on an average of 1951 and 1980. So they used that as the baseline. Okay. And then they set up and said, okay, if it was less than that average, it's below. And if it's higher than that average, it's above. So these years on this graph are higher than the average was in 1980 or 1951 to 1980, that average year. So about 30 years. So yeah, looks like it's going up. Now let's look at this graph. This is also temperature for the past 500 million years. Now, I just said we don't have data for that back since about 1880, right? So how do we get the last 500 million years worth of data? Yes. Yeah, geological records, tree records, ice cores. We have ways to be able to figure out about what the temperatures was over time. So if we look at this graph, so there's your temperature from 50 to 90. And there we are today. So based on this graph, is our climate changing drastically? We're not even close to the highest temperature ever. It's like, it was almost, well, at the beginning, it was almost 100 degrees Fahrenheit. So There was times in our planet's history that we were way warmer today. We weren't around. We've only been around for the last couple million years. So we probably wouldn't survive in that time. Like there's been massive times where there was no polar ice caps. There was no Antarctic polar ice cap. There was no North Pole ice cap. So we're saying, okay, well, the ice caps are going away. Yeah, that's happened. So these two graphs, now, if you look, it does tend to start a pretty good spike at the end. So yeah, there probably is something drastically happening. But this is a matter of what these two graphs were actually shown in forum groups and everything else after they announced that July was the hottest temperature ever in world history. And these were the types of graphs that people were using to argue cases. And that's the thing. It's like these two graphs show similar information. You're going to pick the graph that helps your case. Neither one of these graphs show anything wrong. Everything is accurate about this data. Okay? They just show two different situations. It's like we've had spikes in the past. There's been spikes. It happens. There's major spikes. We had an ice age about 500-600 years ago. It wasn't a huge ice age, like Europe wasn't covered with ice, but it was an ice age. So we're recovering from that. We're still literally recovering. Climate is massive. Like you can't look at a month and go, oh my God, climate's horrible. Climate's hundreds of years of change and how things change over time. So it's changing, and I think we're doing some things to it. And we should do some things to fix it because it's definitely getting hotter. But I don't think it doesn't look nearly as drastic as that graph did. The other thing is, if you look at this graph, it's not even 1 degree Celsius change from the mean. So we look at how we view temperatures. Now, 1 degree over the entire world, that's huge. But some people might go, it's not even a degree. Like, if the temperature changed from 70 to 71 today, I don't think anybody in this room would notice it. Even 90 to 91, most people aren't going to notice it. Okay? But if you look at it over the whole world, and the stuff, places that are cold, places that are warm, the average, it does make a difference. So look at graphs, look at why they're done, and look at how they're done, and look at the information around them. Those are the things that are going to make a big difference. All right, now onto the fun ones. Let's do, I'm trying to find a good one. Anybody remember USA Today? I'm old. So the USA Today newspaper used to have on the front page of every of their sections a little graph that showed data, that showed information. This is one of them. All right. So what information would you pull from this graph? Oh, actually, hold on. Let's ask a simple question first. Is this a time series or a cross-sectional view? This is cross-section. Okay, good. Now that we've got the definition piece out of it, what other information can you get from this graph?
Something in their life is the most common injury.
Okay. Huh? So these are common injuries children suffer. So the thigh bone seems to be the most common injury. Isn't thigh bone that's the bone above the knee, right? It's been a while since I've done, like, I get some, okay. That seems weird that one's higher than the lower leg. I would assume the lower leg would be more, but
Almost the exact.
Huh? Yeah. Yeah, you're right. They're almost the same number. Okay, what else do we get from this graph? What do you think the person who created this graph is trying to get across? So what? Okay. If you see percents, what's the first thing you want to do? Except for run to the hills. Yeah. Okay, so add them up.
I don't think those equal 100.
They don't. The only thing worse would be if this is a pie chart, which we'll show you in a little bit. I hate pie charts that don't add up to 100%. They drive me nuts.
Yeah, it doesn't add up to 100%.
Okay. What does it add up to?
1%.
Okay.
So we got 20% of injuries unaccounted for.
Okay.
Also, it's like kind of misleading. It doesn't say like percent. I mean, obviously, like you said, it doesn't add up. But like, are we just looking at children who are hospitalized? Are we looking at all children?
And what defines a child?
What defines a child?
Yeah, like the age range. It should be like,
Okay.
you could consider
I
a
think-
child 2 years old or 10.
Yes. So in this case, I actually don't know the answer to that question. That's you said what's misleading about it though. Is nowhere does it say, it says the top traumatic orthopedic injuries for which children are hospitalized. It doesn't say if this is out of all children or if it's just out of children that are hospitalized. So if you're looking at this and it says common injuries children suffer, I'm going to look at it and goes, this is all children. So that means 81% of children break a bone. That doesn't sound right. So the data is probably for those that were hospitalized. So out of the children that were hospitalized, this is the most common injury. But nowhere does it say what percentage of children are hospitalized. So it's misleading. And it's misleading to show whatever they wanted to show. I don't remember this one. It doesn't have the date on this one. For all I know, this could have been talking about because when skate parks started getting really big, everybody was worried about people getting injured at skate parks and stuff like that. It's like, so they throw this out there as reasonable. No, you can't have skate parks. So these things come up. All right. I don't want to allow. All right. Let's get this one. Again, I'm going to feel old. Anybody know who Terry Shrivo is? Okay. It's okay. She's dead, unfortunately. So there was a woman in Florida who basically there was a fight between her family and her doctors and stuff like that about assisted suicide. She was terminal and she wanted to die. And there was a major fight between that. And the courts ruled in favor of her ending her life. She wanted that. So this was a poll that was done. And this was a graph that was shown on TV about this case. What are some things you notice about it? Democrats are way higher than Republicans and independents, right?
Republicans and independents both agree at the same level.
Okay. Republicans and independents basically the same level.
Same issue with the last one. How many people are we polling?
Well, that's less important actually in this case. So this is percentage. So whatever they polled, we talked polls probably around 500-600 people, maybe 1,000. They polled enough to get the data.
The scale only goes from 50 to 64. It's made so it looked like the Democrats are way more in favor. Only like 8% more.
Yeah. So this happens quite often in graphs. So if you remember back to elementary and middle school when you actually were making bar graphs, because that's about the time when you make them, One of the things the teachers probably showed you, and they says when you make your things, you're supposed to put a little, right? Maybe if I can, right. You're supposed to put a little break on your graph. So this way, if you're not going to start off at 0, you put a little break to show that you're not starting off at 0. In this case, they didn't do that. Even if you have the break, most people aren't going to recognize it. But they did this on purpose to show that Republicans and independents were less sensitive to her needs by a great margin, like 3 times as much if you look at the way the bars are made. But in reality, Republicans and independents, actually the majority of them did agree with the court case. It was about 54% and 62%. So there was a 8% difference between the two. That's not that big of a deal, but across the board, the majority of them agreed with the court case. So it's another way that they use graphs to manipulate views. And most people just look at the pictures and the words and stuff else. Okay, that's what I'm getting from it. It's like, that's the information we're going to get from it. Let's pull another. Oh, I have a whole bunch of these.
You ever have like a mobile? We don't stuff.
No. No, maybe not. I've maybe. But I don't think that's a horrible thing. Like, yeah, sometimes I think it's good to sleep back and not worry about anything. But depending on what you're looking at, like, I think sometimes having that critical eye is important. And I really think in today's world, it's probably even more important because there is a ton of information that you guys have access to now. And there's so much stuff out there that understanding where things come from becomes important because not everything's as reliable as it should be. This one's, what's wrong with this one? Yeah.
I don't even know what it's trying to say because it's comparing one graph that's 1 minute to like an hour, and I don't understand how those 2 times are comparable.
They're not.
Right.
But if you don't look at the actual numbers, which some people don't want to look at numbers,
No number.
then the graph shows that, yeah, it doesn't make much sense. But it's like, if you look at the bars, oh, lidocaine's better. Just look at the bars. Lidocaine's better. That's what they wanted you to see. And depending on how long this was on the screen, that's what you would have got. So I have no clue what it means. It's there. Also, reading fine print. I'll see if I can find that picture. Before we leave, I'm going to find a very interesting fine print thing to show you. It has nothing to do with graphs, but it's very interesting and funny. All right, let's look at a different one. We'll go back to climate change. It's nice because it's got. All right. So this one's got a little bit of statistics in it, which is a good thing. All right. So we've got the dark red, which says that it's a 75% degree of certainty that that's where it's going to be at. We got the lighter red, which is a 95% degree of certainty. So scientists are 95% certain that the temperature is going to be somewhere in that lighter pink range, including the dark, that whole range. Anybody ever pay attention to like hurricanes and stuff? You know, the cone of uncertainty that they show as it goes out gets bigger. That's in essence what this is. All right. They think it's going to be in the center, but it could be anywhere within that cone of uncertainty. The black line is where the temperature actually is. Okay. So they're saying that, well, the black line's about to go below this. Okay. Does that mean they're wrong? Yeah. Did anywhere say it was 100%? Nope. If anybody ever tells you they're 100% certain, call them a liar. Nobody's ever 100% certain. Yeah.
And also they say climate scientists, which climate science at some like a university.
Yeah. There's,
Like, it's very big. It's like who they're quoting.
yeah. Their goal actually, this graph's the opposite of what we think. This graph is actually trying to show that climate change isn't real because the temperatures are going to be outside of that range. Is what they're trying to show. So we can assume that the climate scientists they're talking about are actually like the climate scientists that actually put out data. But I don't know. But even that, even if it goes below it, it's 95%. That doesn't mean it's 100% guaranteed. Like there are situations like here, it was below. Like it was below that. It can happen. Right? So, but this is one of those ones that they use the information and try to use it against them. To say, I got you. It's not happening. Okay, it's why they say it's a 50% chance of rain. It means if it rains, they're right. If it doesn't, they were right. It's like, okay. Anybody here watch Fox News? Let me rephrase this. Anybody here going to admit that they watch Fox News? Fox News is not always horrible. They have some redeeming qualities. I'm going to pick on Fox News. That's why I asked. What did I just say? I absolutely hate pie charts with percentages on them.
There's a lot of words that are none of them match each other.
It's like words are going off.
Well-
Where's opinion? What does the presidential run have to do? Oh wait, never mind. I thought this was back pain. I was so confused.
I initially read back pain.
Okay. That's funny. I didn't even catch that. That was it.
I thought it said back hurricane.
Well, we called Huckabee Huckleberry, so that's not something unusual. All right, so this was in the 2012 presidential run for the GOP candidates, probably in the primaries. It's Opinion Dynamics. It's a group that does polling data and stuff like that. It wasn't Sorts Opinions. It's Sorts Opinions Dynamics. It's just the way they showed it. But it adds up to well over 100%. A pie chart should never go over 100%. But like most of my high school administrators, they love pie charts. And I don't know why. They always want to put data onto a pie chart. And most of the time, the data they're putting on the pie chart shouldn't be a pie chart. This is one of those cases. So they were literally just trying to show the percentages that wanted to make it look pretty. Yes.
The only way I can see like something like this maybe being like possible if they're comparing like if they're also adding in like GOP voters that weren't present during like the last primary season. Like,
No, it's just you can be okay with multiple people. That's the thing. It's like they just ask the questions. You could be okay with any of the candidates. That's what they're saying basically. It wasn't a one or the other type situation.
No, I meant like the population of registered Republicans like
Oh.
increased from the last primary.
Yeah, maybe.
Yeah, it's
All right, here's another Fox News one, unfortunately. All right. This was Fox Business News. 39.6.
Just 0.6 or by more?
It's a little more than 0.6. But not anywhere close to what this graph tries to show it does. Yeah, the Bush taxes expired. It would have changed the top tax bracket from 35%, which he lowered it to, back to the 39.6, which was the level at which Clinton had it in the 1990s. And which is about the level actually that Biden wants to put it back to, because it's not 39.6% anymore. So that'd be the top tax rate. But again, they're look at the numbers on the side. They're trying to get you to think a different way. All right. It was a really interesting one. Where is it? 13 graphs. Where is this? This one. There it is. Just search misleading graphs on the internet. There's so many of them. This one I thought was hilarious.
Oh, yeah.
Just like, is that upside
The
down?
ones that are upside down. Yeah, I think this one was upside down.
Yeah. So gun deaths in Florida. So
To try to make it look like it goes last.
So, and like, okay. And they even they actually put the red in the right spot. But again, we look at graphs the right way up. So you're going to look at the bottom and go, oh, it's dropped. No, it didn't. It went up. Because the side, and it, as horrible as this graph is, again, all the data on it is correct. So this is one of those situations where you go, okay, you're lying. You're giving us false information. No, I'm not. Everything on this graph is completely and utterly accurate. What you think of the graph is not what I'm telling you. I'm showing you information. So that's the problem with some of these things, is that's why I was saying you really have to start digging a little deeper and start looking at things. Because people will use data that is correct, but show it in a way to show what they want to show. And yeah, it does definitely look like it's going down, but it is most definitely not. It did go down for a little while. It was like 873 back in the early 90s. So it has gone down since then, but it's definitely jumped after they passed the Stand Your Ground law. All right, where was that graph? I'm going to put this one up there. I'm not sure if you're going to be able to actually see what it is, but yeah, I'm not sure you're going to be able to see the bottom. So basically, this is the county. This is the number of cases of deaths and hospitalizations in each of these on the 5 counties in Georgia. These are the 5 counties in Georgia. Okay, so just looking, I'm leaving it purposely small. If you can read the bottom, go for it. But if you can't, that's fine. What do you notice is happening? This would be a time series, by the way, but what do you notice? What do you see is happening over time? Okay. This graph would show you that over time in the COVID cases, the hospitalizations and deaths are decreasing, right? Okay. That's what everybody would got from this graph? Okay. I'm going to zoom in on something. There's a reason for that. And there was a reason they created it so you could barely read it. Can you read the dates now? Huh? They are by days, but
Oh.
Are those jumping around?
yes,
It says the 26th of April and then the 3rd of May.
yes,
The 4th of May.
they organized the data to show that it was decreasing.
That's not how that works.
So literally, they jumbled around the dates to show that things were decreasing, even though
Curious to see
they really
what
weren't.
it looks like.
I don't have one, unfortunately. But this is the problem: is that these things happen all the time, and it's not going to let me shrink it back. It's like this is the type of stuff that happens: is that people make graphs to show something, and what ends up happening is it skews opinion. And the one thing that I see going on now on all social media is we're reduced to memes. We're reduced to a little picture with some information on it. And I can't tell you how many times I've seen people repeat the same memes, and it's like, do you even know what that means or where it came from or anything else? And it's like, I just thought it was funny. Okay, that's fine, but like there's information there. And that skews people's opinions, especially if you see it more and more. And you wouldn't be upset with it if that meme showed what you agreed with. So when people are sharing it, the people that are seeing it are mostly people that would agree with it, so it just keeps spreading. So it's like, look at these things a little more and see where this stuff's coming from, because crazy things like this happen. Did you realize that the number of people who died by becoming tangled in their bed sheets is an epidemic?
Oh, it directly correlates with the amount of cheating per capita.
Yes. How do you know that one? Like, how on earth did you know that?
How do you know that?
Because I literally looked up the graphs.
It's the thing I know. I don't know.
I'm like out of all the things, that was not what I expected somebody to say. It does.
Like a thing with like Nicholas.
Yep, that's on the site too. Yep, I have the graph too. It's like there's some other ones on here. I just found that one hilarious.
Basically, people eat too much cheese.
And then they die in bed. Yes, that's actually where I was going with this one. Correlation does not equal causation. All right, you can correlate some really crazy things. And apparently I finally found something that people know about in this class. Yeah, you can correlate a lot of things. Doesn't mean it's causing it. So there's no causal relationship between cheese consumption and people dying tangled in their bed sheets. There's a correlation to it. It just doesn't cause it. What was the other one?
Question.
Yeah.
How would you like take that information and like prove it?
So actually, in all actuality, this actually is perfectly accurate. Like the correlation is 94.7%. So it's when you're looking at correlation, you're looking at does the data, the closer it is to 1, the more perfectly correlated it is. The closer it is to 0, the more scattered it is. If it goes negative, it's a negative correlation. It can happen. When you were in school, you probably did like scatter plots. A scatter plot's the same thing. It's just as it collapses down to basically a line, the more correlated it is. So they've done these. I don't know why on earth somebody would have chosen these two things to try to pick to correlate. But my guess is somebody was bored on like Google Trends or something like that and just like made graphs that, oh, those look similar, and then stuck it together.
What is your first question? How do you prove correlation is causation? Or like there's a causation behind it?
Okay, so that you need to start looking at the pieces like behind it, like what connections there are between them. So a great one is red cars get more tickets. So the color of the car relates to your tickets. So that's one of those ones that it's like, no, that can't be true. It has, but it is. So they've actually shown that cops will target more red cars. People who buy red cars, typically the red cars are typically sports cars. They typically go faster, so they typically get more tickets. So they looked at those things. They thought there was a correlation or a correlation to it. They found a correlation, and then they said, okay, well, that's causation. Because they are kind of related to each other, like these two things, there's no connections to them. And yes, I do have the Nicolas Cage graph as well. Let me go back to my thing. Here, I'll just share this page because there's a bunch of them that are hilarious.
I think there's like a whole website that finds.
Yes, spurious correlations. So U.S. spending on space science it is correlating with suicides by hanging, strangulation, and suffocation. So the more we spend on science, the more suicides there are apparently. The number of people who drown by falling into a pool correlates to Nicolas Cage's films. Divorce rate in Maine it correlates to the per capita consumption of margarine. That's because all the people from Vermont go, you can't eat margarine, you have to eat cabbage cheese and butter. The age of Miss America correlates with murders by steam, hot vapors, and hot objects. Total. Now this one I can say maybe there is some kind of causation. The total revenue generated by arcades correlates with computer science doctorates awarded in the U.S. Because they all go to the arcade to play games. Per capita consumption of mozzarella cheese correlates with civil engineering doctorates. People who drowned after falling out of a fishing boat correlates with the marriage rate in Kentucky. So, like, there's crazy ones. All right, so it's a funny website. Yes.
What defines the amount of like correlation? Because you'll look at the first one that looks so similar, and then you go down and you see that.
So if hold on, let me zoom in a little bit. So if you look at too close. Oh, it actually lets me zoom up. That's
the
not what I.
almost exact,
Yeah, and that's not what I wanted to. There we go. All right. So if you look, and I don't know if I can make this bigger so you can actually. Hold on a second. Let me try this. Trying to make it so you can actually see the numbers. This one, see, it's 99.79. So basically, when you're looking at correlation, we're going to look at it a little bit later and actually show you how to do the calculations. You're basically looking at the division of the two pieces and how close they are together. In this case, it's 99.79. So that's really close to perfectly correlated. This one's only 66.6. So this one is not as nearly as correlated as the first one was. I think this one's more of a fun one than anything else. Yes.
Yeah, correlations, not even causation, can actually cause actually a lot of harm in our world, because the big reason why people believe vaccines cause autism is because that there's a correlation between them, because the
Yes.
early symptoms of autism appear at the same exact time kids get their MMR vaccine.
Yes. That's actually a very good explanation or reference to correlation and causation. So yeah, they happen to come up like they get their MMR vaccines and stuff like that when they're, I think it's like 1 or 2 years old, and that's when signs of autism starts coming out. Even if you didn't have a vaccine, they would have. The other thing, like with those type of things, is as we get more data, more things start to come out. So, do I think there's more cases of autism today than there was 100 years ago? I don't believe there is. I believe we know about it.
Also, part of it is the world is more overstimulating now.
Yes. Well, that's another total issue. Yeah, that's causing more ADHD and those type of situations where it's like we just have that. But like, there's a lot of things. Like, do we have more cancer today than we did 150 years ago? No, you didn't live long enough to get it. We live longer, so you're going to have more cases of cancer. Yeah.
To the autism thing, I used to be a nurse, like up to like a month ago before I started school. One thing with my older people, like people in their 80s, 90s, is I had a lot of people with autism and different neurological
Mhm.
going on, and they never got diagnosed with it or on medication or something like that. So I question it all the time. I was like, well, why did they go 80, 90 years with this thing and blah, blah, blah.
Yeah.
Get, checked out, got the medications, nothing. And that's similar to what you said is now it's more known about as
Mhm.
well. So
Yeah, we know about it. We have the science has shown us these things exist. So we now can treat them. Where 150 years ago, they were just slow. It's slow. It's fine. he works good with his hands, so he's gonna go be a carpenter. It's like that's what people said. It was just the way it was. So you didn't have all the technology and everything else that we have to diagnose things and look at things and figure things out. So it's like we look at things, oh, things are getting so much worse. It's like not necessarily, we just notice it. So it's like, and that's the thing with data. The more data we have, the more information we have, it overstimulates. It gives us so much stuff to be able to look at, to be able to try to decide what's correct and what's not. All right, one last one before I leave. Let me see if I can find it. Western. Hold on, I know it's in my photos. Oh. Darn it, I'm not going to find it. Ah, there you go. So this was on TV. So all right, so this is what you saw. Oh, sorry, this is not what you saw. This is what you saw. Get $10,000 in one day. Hand you $10,000. Okay. So if you're down in your luck, you need some money. When I look at that, can anybody actually read the fine print? Yeah, it says the APR for a typical $10,000 loan is 89.68%. Okay, with 84 monthly payments of $743.99. Somebody want to do 700? We'll do 750 times 84. That's how much you pay back for that $10,000 loan. Over the course of your 84 months, you would pay back $64,000. Every month you'd have to pay them $750. Yep, for $10,000. So, but this goes back to, like, it doesn't necessarily have to relate to graphs, but it does relate to being math literate. So here is their loans. Okay. I don't need $10,000. I only need a couple $100. Okay, no problem. I'll give you an $850 loan. But I'm only giving you $500 of that. I'm keeping $350 of it to start. Oh yeah, and every month for the next year, you owe me $150. So at the end of the beginning of this, I only gave you $500. And you owe me $150 every month for the rest of the year. It's a 342% interest rate. But you know how many people bit on these things and took these things? All right. The reason, so this is as close to loan sharking as you can get. The reason it was legal is it was on an Indian reservation, which is outside of federal law. So this is why I think like these classes are important, because the more math literate you are, the less scared you are of numbers and things, the better you're going to be able to not be taken advantage of, right? Because the smart people who know all this stuff, they love money. and they will use every little bit to take advantage of you and push an opinion or push a view. So that's why I like these classes, because it's like it gets you to start thinking differently, which I think is important. Like the Mac commercial, think differently. So we will start to do the calculations so you can actually start to understand where the numbers come from next week. So don't worry, math's coming. You should be able to finish everything on Hawks up through the end of chapter 2. Now, we covered chapter 2.1.2 on Tuesday and chapter 2.3 today. I don't believe those are due till the 17th, but you should be able to actually do all the way through chapter 2 at this point. Next week, we'll cover chapter 3. So. Hello. Oh, shoot. Nope, don't want to leave Paul yet. What's up?
I just had a question last.
Oh. Okay.